In this video, I'm going to talk about the ISIS operation over point-to-point links. Also, we can talk about some features of the ISIS, for example, circuit ID, local circuit ID, extended local circuit ID, and some other features of the ISIS. You know that in previous videos I talked about the ISIS three-way handshake. Here we need to talk again about this feature, ISIS three-way handshake, and after that we can verify this functionality, and finally we will learn some new features about the ISIS. Don't forget that this video is for example, for understanding the ISIS operation over point-to-point links, because we need another video to understanding ISIS operation over the broadcast link. Okay, as you can see here, we have R1 and R2 connected to each other with a serial links, and you know that serial link is meaning that we are using the point-to-point network type of the ISIS. Let me to show you first the configuration I did before, because the configuration is same as the other scenarios. Because of that, I did this configuration before this video. Look at here in R1. First, I configured the serial 10 show running config for interface. Serial 10 can show us that we have IP address of 10.121 on the serial 10 interface of router 1 with a /24, and then IP router ISIS. Also, I configured ISIS on this router. Show run section router ISIS can show us that we have the router ISIS command with this net address, and IS type is level 1, and also we enabled log adjacency change. This is the configuration of R1. Also in R2, I used the interface serial 10 or 11 show run. For example, interface serial 11, here you can see that I configured the IP address of 10.122/24 on the serial 11 interface, and I also enabled the ISIS on this interface. Also, if you want, you can check the show running config with the section router ISIS. Here you can see that we enabled ISIS with this net address. The IS type is level 1, and log adjacency change all is configured. Because of that, now we have ISIS neighborship. Show ISIS neighbors can show us that we have neighborship with the router 2. Router 2 is the resolution of the system ID to the host name, you know it. And also the type of our neighbor is router 2, that is L1. The interface that I have neighborship is the serial 10. Look at here, I used intentionally different interface in this scenario because I'm going to emphasize that for example, R1's interface serial 10 is this interface. This is not the neighboring interface. This is the for example, R1's interface, and then the IP address of the neighbor is 10.122. Okay, the state is up, it's okay. The whole time is 28, it's okay. You know the reasons. I talked about all of these features in the previous videos, but now I'm going to talk about the circuit ID. You know that I mentioned in the previous videos that circuit ID is a local identifier for every interface. Let me to talk a little more about the circuit ID, because we didn't talk with detail about the circuit ID. It's not so important, but we should know the function of the circuit ID. The circuit ID's function is for purposes of distinguishing between interfaces of the same node, and IS enumerates its interface by a locally significant one-octet number called the local circuit ID, okay, which increments by 1 with every interface added to the ISIS instance beginning with 0 on Cisco routers. So easy, because you know that, for example, assume that R2 has two interface in the for example with ISIS configuration on these two interface, serial 10 and serial 11. It uses the local circuit ID of the 00, because circuit ID has 1 byte length, 1 octet. Because of that, for example, if R1 has two interface. Let me to show you here. Assume that R1 has two interface with ISIS enable ISIS configuration, and these two interface, it uses a local circuit ID for each of these two interface, local circuit ID. For example, for serial 10, it can uses the 0000 because this is the 1 byte length, and also for the serial 11, it can use the 01. That's it. So easy. This is the locally assigned number to every interface or every circuit in every router, and the purpose of this local circuit ID is distinguishing between interfaces of the same node. So easy. Okay, local circuit ID on point-to-point interface appear only in IIH packets. IIH means IS hello packets, and are only used for detection of a change in identity at the other end of the link. Let me to show you. Look at here. First, we can see the local circuit ID with show CLNS interface. You use the show CLNS interface for informing about the features of the interfaces of the ISIS. Let me to show you. This is the R1. For example, I'm using the show CLNS interface serial 10. Look at here before using this command. As you can see here, we have the circuit ID of 01. This is the circuit ID of the neighbor circuit. Okay, you know that in R2 now we use the local circuit ID of 01. I'm going to show you, and after that R1 can see the local circuit ID from the IIH packet received from the R2. I'm going to show you. First, let me to show you the CLNS interface show of the serial 10 of R1. Look at here. In R1, we can see that here have local circuit ID as 0x100 or 100. This is different with the circuit ID that I mentioned before, because you know that the circuit ID has only 1 byte, but 1 byte length or 1 octet. But here we have a different value for local circuit ID. Why the local circuit ID here is 0x100? This is because the implementation or internal implementation of the Cisco. This number is actually wider than 1 octet. This is just Cisco's internal implementation that enumerates point-to-point interface with local circuit ID starting with 0x100. Let me talk about this. Look at here. 0x100 means 256. Why? Because this is a hex value, and if you want to convert this hex value to decimal, you can see that this hex value equal to the 256 in decimal. Okay, Cisco uses the first interface. For example, for serial 10, the 0x 100. And then for serial 11, Cisco uses the, for example, 0x101. That's it, okay? In router 1, because this is the first interface, the ISIS uses this local circuit ID for this interface. This is equal with the 0. Okay, in the IIH packet, you will see the 0 in the local circuit ID. And also, let me to show you the R2's local circuit ID for serial 11 show CLNS interface. For example, serial 11 can show us that here the R2 selected or used the local circuit ID for the serial 11 as 0x101, means 1. Okay, look at here, serial 11. Now this is random, it's not important. Maybe in your scenario you can see 0x100. Okay, 1x101. Okay, because of that, in R1, when we are using the show command, look at here, in R2 we have 0x101. This is the local circuit ID of R2 serial 11, and in R1 we have 0x100. Look at here in the R1, when you use the show is neighbors, you can see that the R2 as our neighbor uses